let's you and I talk about mathematics. I guess the FAA figures if you want to be an A&P and work on aircraft like this, you need to know something about mathematics. I think they're working on the theory that if you understand mathematics, you'll be more accurate, more precise. Basically, they might be working on the idea that figures don't lie. On the other hand, maybe they've forgotten an even more important principle, and that is liars can figure. Let's see if you and I can figure out mathematics. Now, mathematics is kind of the language of numbers. It's how we communicate about numbers. So let's you and I lead off by talking about some terms. The first term we want to talk about is the term factor. We're going to say a number is used as a factor. What does that mean? Well, it means it's used in multiplication. If it's used as a factor, it's used in multiplication. For instance, they're going to say, what does the number 9 with a little 4 in the upper right-hand corner mean? Well, that means that 9 is raised to the 4th power, or 9 is used as a factor 4 times in multiplication. In other words, 9 times 9 times 9 times 9, using it 4 times, is 9 to the 4th power. And if you want to figure it out, you use your electronic calculator and you get an answer of 6,561 there. Using a number 3 times as a factor is expressed as 64 in this case, the number 64, with the 3 up there. That's 64 raised to the 3rd power. Another way of expressing that is 64 cubed. That's the cube of 64, and that's using 64 as a factor 3 times. In that case, it'd be 64 times 64 times 64, or 262,144. All right, now they're also going to ask you, what is the square of a number? Well, that's raising a number to the 2nd power. For instance, here is 212 to the 2nd power, or 212 squared. That means the number is used as a factor 2 times. For instance, 212 times 212, the number is used as a factor 2 times. Multiply it out, the answer is 44,944, and that's 212 squared, or 212 raised to the 2nd power. Now, here comes a tricky one. What does 3 to the negative 4 power mean? 3 to the minus 4 power. Well, that means 3 is used to be as a factor 4 times, but it's 1 divided by 3 4 times. So it's 1 over 3 times 3 times 3 times 3. If you use your calculator, 3 times 3 times 3 times 3 is 81. And it means 1 divided by 81. So that's 3 to the minus 4 power. You're going to see that later on. Now they're going to ask you, what is the square root of a number? Well, the square root of a number is a smaller number that when it's multiplied by itself will produce a larger number. The square root of 1,746 you'd work out with your calculator. By the way, 1,746 to the 1/2 power is the same as the square root of 1,746. Now you and I are going to do this with our calculator, and we're going to get an answer of 41.7852. Let's do it. Here's 1,746. We'll just key that into the calculator. And notice right here, your calculator has a square root button. Now on the test, make sure you do go to the test with a calculator that does have a square root button, because it's going to make it a lot easier. So you just hit that square root button, and you find out the square root of 1,746 is 41.785. 7852, we called it here, and it's 41.7852. Now what that tells you is if you multiply 41.7852 times itself, you'll get 1746. And that means the square of 41.7852 is 1746, and the square root of 1746 is 41.7852. See, nothing to it. Now, another thing they can do to you is ask you the square root of kind of a big number, like what's the square root of 3,722.1835? Well, once again, it's just a little calculator problem. So if you take a look at the calculator, all you have to do is key in 3,722.1835 and then hit the square root button with that big finger there, and you get 61.0097. There you go, 61.0097. So all you have to do for square root is use the square root button. Nothing to it. Now let's take a look at a question they're going to ask you about square roots. They're going to say, take the number 8,019.0514, multiply it times 1 divided by 81, and that is equal to the square root of what number? Well, to solve this problem, the first thing we have to do is do what they tell you to do. Take this number and enter it into the calculator. It's 8,019.0514. And instead of multiplying times 1 divided by 81, all you have to do is divide by 81. That's the same thing, so divide by 81. And when you do that, you get the number 99.00634. They're going to ask you, that's the square root of what number? Well, to find out what it's the square root of, what you have to do is square it. And to do that, you multiply it times itself. On this calculator, all you have to do is hit the times button and the equal sign, and now you've squared it, and the answer is 9801.1255. Forget the 1255, and the answer is 9801. And that's all there is to it. To find the square of a number, you multiply it by itself. Now let's take a look at a question that's just a little more complicated. What they want you to do is figure out the square root of this expression. And the expression, of course, is a little complicated. It's minus 1776, it was a good year, by the way, divided by minus 2, and then when you get done doing that, you subtract 632, and when you get done with the whole thing, you'll take the square root of it. So let's resolve the things in the parentheses to begin with, and minus 1776 divided by minus 2 can be expressed as a fraction, and that's kind of handy. And then you subtract 632 from that, and then take the square root of that, and we'll have our answer. Okay, first of all, these minus signs actually cancel each other out. So if you want to use your calculator to do this, all you have to do is take 1776 divided by 2, and you find out that that expression works out to 888. So now it's 888 minus 632, so all we have to do is subtract 632, and we'll subtract that, and we get 256. Now they want to know the square root of this, so it's the square root of 256. So using your handy dandy calculator, all you have to do is hit the square root symbol and you get 16, and the correct answer is 16. So see, with this calculator, there's nothing to it. Now let's take a look at powers of 10. 10 is a magical number. We have a mathematics system based on 10. So a lot of things are very easy when you're dealing with the number 10 or 100 or 1,000. These are all powers of 10. For instance, 10 to the first power, 10 used as a factor once, and this makes sense, doesn't it, is 10. Now, 10 used as a factor twice is 10 to the second power, or 10 squared is another way to say that. And that's 10 times 10. That's 10 used as a factor twice, and you can see that that is 100. I think you're getting on to this. 10 to the third power is 10 times 10 times 10, and that's 1,000. Now all you have to do then, as you can see, 10 to the fourth power is now 10,000. Just keep adding zeros. 10 times 10 times 10 times 10 is 10,000. So when you're working with tens and you increase the power, all you have to do is add a zero. You can see this is 10 to the 1 power, 2 powers, 3 powers, 4 powers. We just keep adding zeros. You can see it coming. 10 to the fifth power is 10 times 10 times 10 times 10 times 10, and that's 100,000. All we did was add a zero. And the last one, my favorite number, is 10 to the sixth power, and obviously we got 6 tens here. And how many zeros do we have? Well, we know how many zeros are in a million, don't we? 6 zeros, and it's 1 million, 10 to the sixth power. So you can see when you're working with 10 and you increase the power by 1, all you have to do is add zeros. Now let's take a look at 10 to the minus powers. We can start over again. 10 to the 1 is 10. Divide that by 10 and you reduce the power by 1. Each time you divide by 10, you reduce the power by 1. Multiply by 10, you increase the power by 1. So 10 to the 0 is 1. By the way, any number to the 0 power is 1. So 10 to the 0 is 1. 10 to the minus 1, now here's the fun part, is 1 divided by 10. It's written as 0.1. 10 to the minus 2 power is 1 divided by 10 times 10, or 1 divided by 100, and that's written as 0.01 or 1/100th. This is a tenth, this is a hundredth. 10 to the minus 3 power, you're getting on to this, is 10, 1 divided by 10 times 10 times 10. And notice the digit words that's important is the third one after the decimal point. First one after the decimal point, 10 to the minus 1. Second one after the decimal point, 10 to the minus 2. Third one after the decimal point, 10 to the minus 3, and that's 1,000th. 10 to the minus 4 is 1/10,000th, and the same thing is 1 divided by 10 times 10 times 10 times 10. 10, that's 1/10,000th. 10 to the minus 5 is 1 divided, and you do it 5 times. If you want to count up, it's the fifth number after the decimal point. 1, 2, 3, 4, 5. You got it, see, nothing to it. And finally, 10 to the minus 6 is 1 divided by 10, 1 divided by 10, 6 times, and it's 0.0000001, and that's the sixth number after the decimal point. Now you're going to find that comes in extremely handy as we work around here. So let's take a look at the next question they're going to ask us about this. They're going to say the power of 10, which is equal to a million, is what? Well, if you go back to the table, the power of 10 that's equal to a million, here's a million, it has 6 zeros, and it's 10 to the 6th. So the power of 10 that's equal to a million is 10 to the 6th. They're going to say, okay, what is the value of 10 raised to the negative 6th power? The value of 10 raised to the negative 6th power, that's 10 to the minus 6. And that is 10 to the 6th power is 0.000001. And there it is right there. And you can see that it's easier to express that as 10 to the minus 6 than it is to write all those zeros down there. So that's what scientific notation is all about. That makes it easier to express numbers when you got lots of zeros in them. Now here's how you can use scientific notation. They're going to say to you, what is 16,300 equal to? And the answer is it's equal to 1.63 times 10 to the 4th power. Let's see if we can make some sense out of that. First of all, we'll start with the number 16,300. Then, if you remember, by the way, any number to the 0 power is equal to 1. So 10 to the 0 power is still 1. So 16,300 times 10 to the 0 means simply 16,300 times 1. The answer is still 16,300. So you can see now that this number is the same as this number. Now, if I divide this number by 10,000, I move the decimal point 4 places to the left. 1, 2, 3, 4. Then it becomes 1.63. But if I divide it by 10,000, I have to increase this number in order for the answer to still be the same by 10,000. So I just raise it 10 to the power of 4, and that's the same as multiplying that number by 10,000. So now 1.63 times 10 to the 4 is exactly equal to the same thing as 16,300. All I did is divide this part by 10,000 and multiply this part by 10,000, and it's the same thing. Well, when you get to very, very big numbers, this could be 10 to the 27, this makes it a very easy way to express it. So it's 1.63 times 10 to the 4, and that's equal to 16,300. Now here's the case in which they're going to start off with scientific notation and ask you to translate it into English. So they're going to say the number 3.47 times 10 to the negative 4th power is equal to what? The answer is equal to 0.000347. All right, let's do it together. First of all, we have 3.47 times 10 to the minus 4. We're going to just express that just a little bit differently. It's the same thing. We'll just put some zeros here. 0.0347 times 10 to the minus 4. We just put some zeros there. You can see it's still the same thing. Now, let's divide one part of this by 10,000 and multiply another part by 10,000. To multiply by 10,000, you increase the exponent of a number by 4. So you take 10 to the minus 4, multiply it by 10,000, it becomes 10 to the 0. Of course, 10 to the 0, as you know, is 1, but it works out that way. All right? Now, since we've increased this to by 10,000 here, we'll have to divide this side by 10,000. So we'll take this decimal point and move it 4 places to the left. 1, 2, 3, 4. And that's easy to remember the 4, by the way, because we increased the exponent by 4. So we move the decimal point to the left by 4 to compensate for that. And we do that, and we get 0.000347, and 10 to the 0 is 1, so you can just forget that, and the number now is 0.000347. So anytime you want to increase a number by 10,000, you just raise the exponent by 4, and if you want to decrease a number by 10,000, move the decimal point 4 places to the left. By the way, that exponent by 4 only works if it's a power of 10. You can't do it with any other number. But if you want to increase 10 by 10,000, raise the exponent of the number 10 by 4. Now here's another way they're going to ask you the same kind of question. They're going to say, what is the square root of 124.9924? I've never really wondered that a whole lot. And we'll do that with a calculator. And let's do it right now with a calculator and see what the square root of 124.9924 is. All you have to do is key in the number 124.9924. And then you use the square root button. Once again, you got to have that square root button. And the answer is 11.18. So here we are. We find out the answer is 11.18. What's another way of expressing that? Well, let's take the calculator away for just a second. We'll take a look at another way of expressing that. And that is we'll take the 11.18, and they're going to say, is that equal to 1,118 times 10 to the negative 2nd power? Well, all you have to do, negative second power, is move the decimal point down 2. And so 11.18 times 10 to the 0 is what we start off with. Now, if you increase this by 100, multiply it by 100, you move the decimal point 2 places to the right. We do that. And you would also, if you do that, have to divide this by 100. All you do is lower, in a case of 10, the exponent by 2. So instead of 10 to the 0, it's 10 to the minus 2. And you can see that these two numbers are exactly the same. All we did here is move the decimal point 2 places to the right, and therefore we multiplied by 100. And to make this product come out to be the same, we have to divide this factor by 100. So we make it a minus 2, 10 to the minus 2 instead of 10 to the 0. And you can see it's exactly the same thing. So you're going to have to be pretty handy with your exponents of 10. But if you understand what we're doing right here, you got it made. All right, let's take a look at another example. They're going to say, all right, super mechanic, what is the square root of 1824? Well, the square root of 1824 is another one of those calculator problems. So let's you and I whip out the trusty old calculator. We'll punch in 1824, and then you hit the square root button, and you get 42.708. All right, now let's pull away the calculator and see what the rest of this question is. It's also equal to 0.42708 times 10 to the second power. How do we get that? Well, 42.708 times 1 is still the same thing, and 10 to 0 is 1, if you remember. And so if we want to make that equal to 0.42708, what we're going to have to do is move the decimal point 2 places to the left. That's dividing by 100. If you divide this side of the product by 100, you have to multiply this side by 100, and so that's what we did here. We took 10 to the 0 and raised it to 10 to the 2. That's adding 2 zeros to it, or multiplying by 100. And you can see once again, these two numbers are equal to each other. So you have to be able to recognize that on the written exam, and that's all they're asking for. Now, sometimes they'll combine taking square roots and raising powers all in the same question. Here's an example. They're going to say, what is the square root of 16 raised to the 4th power? Notice, who cares, is not a correct answer on any of these. Not at all. All right, let's take a look at it. First of all, let's use the calculator and find out the square root of 16. We'll enter 16, and then we'll hit the square root button. And the square root of 16 is 4. That happens to be 4 to the 1st power. We want to raise it to the 4th power. So we'll just multiply times 4, and that raises it to the 2nd power. And when we do that, it gets 16 to the 3rd power. We'll multiply by 4 again. And we get 64, and raise it to the 4th power, multiply by 4 again. And you should get 256 instead of, again, you do. So that's how you do it. You just simply work it out mathematically on a calculator. All you need to know is that 4 to the 4th power means multiply times 1, multiply 4, is use 4 as a factor, I should say. It should be precise there. 1, 2, 3, 4 times, and that's exactly what we did. Let's take a look at another one they're going to do. Say, what is the square root of 4 raised to the 5th power? Well, once again, who cares is not a correct answer, but let's take a look at that on the calculator. Square root of 4 raised to the 5th power. All right, square root of 4, we'll punch in 4 to begin with, and then we'll use the square root button and find out the square root of 4 is 2. We might have known that to begin with, but what the heck. All right, now all we have to do is use that as a factor 5 times. We've used it once now, and so multiply times 2, and that's using it a factor a 2nd time, times 2 again, 3rd time, times 2 again is the 4th time, and times 2 again is the 5th time. And now we find out that the answer is 32. Remember, raising something to the 5th power is using it as a factor 5 times. We use 2 5 times, and we get 32. See, nothing to that either. All right, now they're going to ask you, what is the result of 7 raised to the 3rd power plus the square root of 39? Oh, no. All right, 7 raised to the 3rd power means you're using 7 3 times as a factor. So let's you and I use 7 3 times as a factor. And all we have to do is use the electronic calculator, punch in 7, multiply that times 7, and that's using it the 2nd time, multiply that times 7, and that's using it the 3rd time, and we get 343. So 7 as a factor, used as a factor 3 times is 343, and that's 7 raised to the 3rd power. Now we want to add that number, 343, to the square root of 39. So all you have to do is take your calculator and punch in 39, and take the square root of it, and we get 6.2449979. Now you keep that number and add 343 to it, and you get 349.24. That's the way you're going to do this on a test. So if you just have an electronic calculator with you and understand the language, and that's all we're talking about here is the language, and if you understand that, you got it made. All right, now let's talk about something simple, very similar, converting fractions to decimals. First of all, the decimal, which is most nearly equal to a bend radius of 31/64 is what? All you have to do to solve this problem is take your electronic calculator and divide 31 by 64. So punch in 31, divide by 64, and you find out the decimal is 0.4837. So let's take a look at that answer up there, and we got it right, 0.8437, I should say, 0.48437. All right, now they're going to say, let's take a look at another one. The radius of a piece of round stock is 7/32. Now the decimal, which most is nearly equal to the diameter, is what? Well, first of all, let's take 2 times 7/32, and you multiply the numerator by 2. Don't leave the denominator alone, and that becomes 14/32. Now all you have to do, because we're using a diameter, remember the diameter is twice the radius. So the diameter is all the way across, radius is halfway across. And so now we have 14 divided by 32. All we have to do is use the electronic calculator to do that. So let's you and I take the electronic calculator, punch in 14, then divide by 32, and you should get 0.4375, and son of a gun, we did. We got 0.4375. Now let's take a look at an exercise involving adding fractions. And the thing you need to know about adding fractions is anytime you add fractions together, you have to have the denominator the same. Here's the question. The decimal, which is equal to the mixed number 1 and 7/32, is what? Well, let's do it. First of all, we'll have to take the 1 and add it to the 7/32. You can't do that. So let's make 1 a fraction. And you do that, it becomes 32/32. That's equal to 1. And once again, it has to be in 30 seconds because to add fractions together, the denominator, the bottom half, has to be the same. So you take the 32/32 and add it to 7/32, and you get 39/32. Now notice the big numbers on top. That's called an improper fraction. But don't worry about it. We're going to keep it that way. Now, all we have to do is use the electronic calculator, divide 39 by 32 to find out what the answer is going to be. And when you do that, you divide 39 by 32, and you get 1.2188, or 875. We rounded it off to 88. All right, so to add fractions together, you have to have the denominator the same. All right, let's take a look at another question. The decimal, which is most nearly equal to 77/64, is what? That's real simple. We've done it before, but let's do it again real quick. Use the electronic calculator. Divide 77 by 64. That's what a fraction tells you to do, is divide. And when you do that, you get 1.203125, and we rounded it off and got 1.2031, and that's what they got on the test. All right, now the decimal equivalent of the fraction 43/32 is what? Now, that's once again called an improper fraction. No problem. All you have to do is whip out your trusty old calculator and divide. So let's do that real quickly. And it simply says divide 43 by 32. So you do that real quickly with your calculator, and when you do that, you get 1.34375, and there we got it right there. Now let's take a look at another question. Here they say which fraction is equal to 0.025. So what they've done in this case is they've given you a decimal and they ask you which of these fractions is equal to that decimal. Well, it's pretty easy. You can use your calculator and just do exactly what it says to do. For instance, let's take a look at A here. It says 1 divided by 4. That's what that fraction tells you. So you use your calculator and do 1 divided by 4 and you get 0.25. Well, it's close, but it's no cigar. So let's do what B tells us to do. And that's 1 divided by 400, and 1 divided by 400, and I get 0.0025. Still doesn't work. I'm going to guess that 1 divided by 40 is the answer, so let's do that, and we get 0.025. So the answer is just do what the fraction tells you to do until you get the decimal you're looking for. Let's do another one. We'll make it a little bit more complicated on this one. It says, what is the fractional equivalent for a 0.0625 thick sheet of aluminum? Well, once again, all we have to do is do what it says to do. So let's use the calculator, and we'll do 1 divided by 32, and we get 0.03125. That's not a correct answer. We're looking for 0.025. 0.0625. Now we'll do 3 divided by 64, and son of a gun, we get 0.046875. Well, that's not it. I'm going to bet the last one is. 1 divided by 16, and you get 0.0625, and that is the correct answer. So once again, just do what the fractions tell you to do with your calculator. Let's do one more, and this one is a little bit more complicated yet. It says a blueprint shows a hole of 0.171875 to be drilled. Which fraction size drill bit is most equal? Well, boy, that's a big number, but let's take a look at it and see what we can do. Let's do, first of all, 11 divided by 64, and bingo, we hit it right off. It's 0.171875, and we got it exactly correct. So in this case, all you had to do is divide 11 by 64, and you got it. Now let's talk about solving equations. They're going to ask you a few questions on the FA written exam about solving equations. Some rules of thumb will be helpful for you here. First of all, use a calculator. You'd be surprised how much sharper your calculator is after taking the written exam for a while than your brain is. All right, let's get some rules about multiplying with plus and minus signs. To review this, you might remember if you multiply a plus times a plus, the answer is a plus. A minus times a minus, the answer is still a plus. How about a plus times a minus? Then the answer is a minus. All right, now let's take a look at an equation, and there's one other thing I need to tell you, is when you have an addition inside brackets or parentheses, you've got to get rid of that addition or subtraction before you can multiply. So the first thing you do is get rid of these parentheses. Let's take a look at how we're going to do this in an actual case. We'll take a look at this question right here. First of all, it says 4 minus 3 times the bracket or the quantity minus 6 times 2 plus 3, quantity closed, plus 4, quantity closed again. How about that? All right, now here's what we have to do. Let's get rid of everything inside the quantities first. So we'll leave the 4 minus 3, that stays the same. But let's take this 2 plus 3 and add them together, and that makes it 5. Okay, and then that's how we finish off this right here. Now let's continue, and let's get rid of the next bracket. So the next bracket is minus 6 times 5, that's 30. So now we have 4 minus 3 times the quantity, 30 plus 4. You see, we're resolving all the things into brackets. Now let's take a look at the minus 30 plus 4. What are we going to do with that? Well, just add them together algebraically, and that comes out to minus 26. So we now have 4 minus 3 times minus 26. Now we can multiply that minus 3 times minus 26. What's a minus times a minus? You're right, it's a plus. So it becomes 4 plus, and 3 times 26, 3 times 6 is 18, 3 times 2 is 6, carry the 1 is 78. So it's 4 plus 78, and we can do this one in our head. We don't need the calculator for it, but 4 plus 78 equals 82. So that's how we do it. We're going to just take a look at all the brackets and get rid of the brackets before we multiply anything. Let's do another one. Make sure we understand what we're talking about here. Let's make sure I understand what we're talking about anyway. Okay, here we have minus 6 times the quantity, minus 9 times the quantity, minus 8 plus 4, quantity closed, minus 2 times the quantity, 7 plus 3, quantity closed, and quantity closed again. Well, how about that for complicated? All right, all we have to do now is get rid of the quantities. So minus 8 plus 4 becomes minus 4. We took that down, squoze it down to that right there. All right, let's take a look at the next thing we can get rid of. 7 plus 3 becomes 10. So now it becomes minus 6 times the quantity minus 9 times the quantity minus 4, quantity closed, minus 2 times the quantity 10, and quantity closed again, and quantity closed again after that. All right, now let's get rid of the brackets again here. We've got brackets here. So what's minus 4 times minus 9, or minus 9 times minus 4? Well, once again, a minus times a minus is a plus, so that becomes plus 36. 4 times 9 is 36. Minus 2 times 10 becomes minus 20, because a minus times a plus is a minus, so that's minus 20. So now we have 36, 6 times the quantity, 36 minus 20. Quantity closed. Now let's get rid of the brackets here. What's 36 minus 20? You got it, 16. So it's minus 6 times 16. And this time, let's use the electronic calculator. I don't want to get too carried away. So it's minus 6 times 16 equals minus 96. See? Nothing to it. It's all too easy for everybody. I can see that right now. So let's you and I do another one. First of all, we got brackets around this whole expression here, and it's divided by 2. And then inside here it says the quantity 4 times minus 3 plus the quantity minus 9 times plus 2. All right, now the first thing you and I would like to do to make this easy, let's simplify things by getting rid of these brackets, because all this whole expression is divided by 2, so all we have to do is put this whole expression over 2, and we got the same thing done right there. That way we got rid of the brackets and simplified it. Now, next, let's get rid of the things inside the parentheses. So what's 4 times minus 3? Well, 4 times 3 is 12, and a plus times a minus is a minus, so that becomes minus 12 inside the brackets there. And let's squeeze this one down. That's minus 9 times 2. That's obviously minus 18. So we now have minus 12 plus minus 18. Well, it's minus 12 and minus 18. That becomes minus 30, and it's all divided by 2. So minus 30 divided by 2, and you can do this one in your head, comes out to minus 15. So once again, you can see the trick to all of these equations is going to be get rid of the brackets first. That's all there is to it. Let's do another one. First of all, this one looks like this. It's 64 times 3/8 divided by 3/4. Now, what they want you to know here is what do you do when you have to divide with a fraction? Well, what you do, let's rewrite this, by the way. It's really 64 over 1, because we want to make these all fractions. That's what we're trying to do here. Times 3/8, and it's still divided by 3/4. Now, 64 over 1 times 3/8, everything stays the same. But to divide by 3/4, what do? You multiply times 4/3. Just flip this thing around and make it 4/3, and now you can multiply. That's easy, isn't it? All right. Now, let's take a look at what we did here. We have a 64 and an 8. You can divide both of these. You can divide, by the way, the top and bottom of all this, and it comes out the same. So to simplify it, we divide by 8. 8 divided by 8 is 1. 64 divided by 8 is 8. And now we have 8 over 1 times 3 over 1 times 4 divided by 3. And by the way, look at this. I got a 3 here and a 3 here. I could divide by 3 in each of those. And let's take a look further down and see what we have next. And son of a gun, when we got rid of the 3's, now it becomes 8 times 4, because the 3 is gone. And 4 times 8 is what? 32. Nothing to it. Just as easy. It's duck soup. All right, let's do one more yet along here and see what we get this time. And this time we get 32 times 3/8 divided by 1/6. You got it. Let's make them all fractions. 32 over 1 times 3/8, still divided by 1/6. What are we going to do with that division? You've got it. Flip it. Now it's 32 over 1 times 3/8, this time times 6 over 1. Now we can get rid of a few things. Let's take a look at it. First of all, I see right off here we have an 8 and a 32. We could divide each of those by 8. And the 8 becomes 1. The 32 becomes 4 when you're divided by 8. So now we have 4 times 3 times 6. And 4 times 3 is 12, and times 6 is 72. And the correct answer is 72. Now here's another kind of question they ask you, and it looks a little complicated at first, but when you work it out, it's really pretty simple. What they're going to do is give you this expression you have here at the top, and they can say, what does that equal to? Well, the rule of thumb is whenever you have an expression like this with parentheses in it, you do what's in the parentheses first. So what we're going to do is keep simplifying this expression and get the answer. So first of all, it says 1/2 times the quantity minus 30 plus 34, and then you take that and multiply it times 5. So we can express the 1/2 as a fraction, 1 divided by 2, and that's times the quantity minus 30 plus 34 times 5. And now we can simplify this expression here. Minus 30 plus 34 comes out, you can do that in your head, it's 34 minus 30 comes out to 4. So it's 1/2 now times 4, and then times 5. So 1/2 of 4 is 2, so now we're down to 2 times 5, and the correct answer is 10. So when you simplify the expression inside the parentheses first, it all falls into place for you. Well, that was too easy for everybody, so let's just do another one. This one says take the quantity minus 3 plus 2 times the quantity minus 12 minus 4 plus the quantity minus 4 plus 6, and then multiply that times 3. And what does that equal to? Well, let's